All right, here is the video for the Unit 4 practice test. So looking at concept A, I can recognize transformations on and off the coordinate plane. So number 1 says label each image as an example of a translation, reflection, rotation, or none. Then explain your reasoning for each. So if we look at A, and I'm looking at my figure, so say if we're taking this figure and we're translating it to make this one. Well, as we can see, it flips over. So it kind of rotates. So it doesn't just flip like a mirror image, but it looks like we would rotate this figure to the right, completely upside down, and it would create this figure. So this is going to be a rotation, particularly a 180-degree rotation, because the figure is turned. Upside down. B, looking at this figure, this shape goes to this shape, and as we can see, it looks like a mirror image. So in this case, that's going to be a reflection because it's a mirror image. If we look at C, so if we look at this type of transformation, it looks like the shape got bigger. Well, remember the types of transformations we talked about, it's the same size and the same shape. So this is not going to be a translation, reflection, or rotation. So this is going to be none. And I'm going to say because the figure, or the triangle, got bigger. All right, lastly, let's look at D. So in this case, it looks like the figure slid. So it looks like it moved right and then down. So that means that this is a translation. So to figure out how many units we should, well, in this case, it's kind of hard to tell. So we're just going to say translation right and down. And the reason we know it's a translation, it's because the triangle just moved. So it didn't rotate and it didn't flip. All right, number 2 says line segment CD has endpoints at -2, 3, and 5, 7. Drill translate CD by the rule x minus 4 and y plus 3. What are the coordinates of the new segment C prime, D prime? Well, we know that this is a translation. Basically says we're going to subtract 4 from the x coordinates, and we're going to add 3 to the y coordinates. So that means C prime. So if we minus 4, -2 minus 4 is -6. And then for the y coordinate, we're going to add 3. So 3 plus 3 is 6. Now let's look at D prime. So we're going to do the same thing. We're going to subtract 4. So 5 minus 4 is 1. And then we're going to add 3. 7 plus 3 is 10. So there's my new coordinates. All right, number 3 says line segment WZ has endpoints 3, -2, and Z, 6, -4. It was transformed to W prime Z prime with endpoints 3, 2, and 6, 4. Write the transformation that sends WZ to WZ prime. So it looks like in this case, the X coordinate stayed the same, but the Y coordinate changed to the opposite sign. Let's just sketch a graph of this real quick to see if we can think of what it looks like. So WZ was 3, -2, maybe somewhere around here. And then Z was 6, -4. So 6, -4 might be right here. So that's W, Z. And then it tells us that W prime is 3, 2. So 3, 2. And Z is 6, 4. So when we sketch a picture here, we can see that this is actually a reflection over the x-axis. So remember, when the y-coordinate changes, it's a reflection over the x-axis. All right, the next problem, so it says triangle A prime, B prime, C prime. So that is this triangle right here, was transformed to create triangle A double prime, B double prime, C double prime. Determine the transformation used to form that triangle. So in that case, that looks like a mirror image, so that's going to be reflection. And it's over the line the y-axis. Okay, now it says triangle ABC, which is this triangle. Oops, triangle ABC was transformed to create triangle A prime, B prime, C prime. Determine that transformation. So in that case, it looks like it just moved down. So 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, 6. So that transformation looks like it's a translation down 6 units. All right, now let's look at concept B. So concept B is I can perform rigid transformations on a coordinate plane. So it says draw and label the image produced when triangle XYZ is reflected across the y-axis. So first I'm going to figure out where the y-axis is. So the y-axis is this axis right here. So to do the reflection, we want to count how far away each point is from that line. So starting with Z, Z is 1 to the left, which means Z prime. It's going to be 1 to the right. Y is 3 to the right, which means Y prime is going to be 3 to the left. And then lastly, X is 1 to the right, which means X prime is going to be 1 to the left. All right, 1B says XYZ is reflected across the line Y equals 1. So the line Y equals 1 is going to be a horizontal line. Remember, that's Y equals 1 because every Y value on that line is equal to 1. So to reflect it, we're going to do the same thing that we just did. We're going to count how far away each point is from the line. So 1 is Y below, or Y is 1 below. So Y prime is going to be 1 above. X, we have 1, 2, 3, 4 below. So we're going to count 1, 2, 3, 4 above. And then Z is 2 below, which means Z prime is going to be 2 above. All right, so number 2 says we're going to take triangle ABC, we're going to translate it up 8, and we're going to label it A prime, B prime, C prime. So I'm going to take each point, I'm going to count 8 units. So 1, 2, 3, 4, 5, 6, 7, 8. So that's going to be C prime. 1, 2, 3, 4, 5, 6, 7, 8. There's A prime. 1, 2, 3, 4, 5, 6, 7, 8. There's B prime. Now it says translate triangle A prime, B prime, C prime. Write 4 units and label the new triangle A double prime, B double prime, C double prime. So 4 units. 1, 2, 3, 4. There's A double prime. 1, 2, 3, 4. C double prime. 1, 2, 3, 4. That's B double prime. So now let's write down the vertices. So A double prime is 6, 5. B double prime is negative 2, 1. And C double prime is negative 1, 2, 3, 4, 5. All right, last problem. It says draw and label the image produced when KLM is rotated 90 degrees clockwise about the origin. So I'm going to try and do the patty paper method, since that seems to be the method that most people are using in class. So to do the patty paper method, you have to trace your figure. Then you're going to select the dots or the lines, and we're going to do the rotation. So 90 degrees clockwise, that's 1 turn to the right. So I'm going to do 1 turn to the right, which looks to be approximately there. Now we're going to plot our points. So here's 1 point, oops. And then our next point is right here. And then the last point is right here. So this is M prime, L prime, and K prime. Another way we can do this more accurately is using the coordinate point method. So to do that, you're going to turn your paper the 90 degrees, and we're going to write our new coordinates as though we have a new X and Y axis. So M prime we know is 1, 2. K prime is going to be 8, 4. And then L prime is going to be 4, 7. Then what we do is we take our figure and we rotate it back 90 degrees to the original, and we're going to plot these points. So M is going to be 1, 2. So there's M prime. K is 8, 4. And L prime is 4, 7. So you get the same result without using the patty paper.